guys. Okay, so let's start with the periodicity exam review. Okay, so if you guys remember, I gave you some notes in the back, and hopefully you used them wisely to help you practice with the exam, so you can study. Okay, so basically, you're going to be given the trends. You do need to remember that as you go to the right, smaller, bigger, you do need to remember this, what increases and decreases. Pretty much, if you really, if you know this too, like ionization energy and they both increase from going from left to right. Atomic radius is the only one that does the opposite. Okay, or you can remember atomic radius that it decreases, it becomes skinnier as it goes up and to the side, to the right, and becomes skinnier when, or actually it becomes bigger when it goes down. Then the rest is the opposite. Okay. So anyways, these are some trends, and also you gotta know valence electrons. This is just repeating itself again. You do need to know also electron configuration. You have to go in the order, and then you have to go S, P, D, and then F. Okay, and again, this is the atomic radius. Okay, so all of that is important. So anyways, let's go ahead and get started. Um, so what we're going to do, okay, so let's start by taking out, make sure you click on the periodicity exam review. Most of it you can write it down or type it in, actually. You can type it in. There's some stuff, but I'll help you out since I'm going to write it down for you. So whatever you're going to write, I'm going to show you how you can type it in as well. Okay. Anyway, let's get started. Okay, so how did Dmitry Mendeleev arrange the periodic table? So he arranged it based on the atomic mass. He went based on its weight. Okay, it kind of threw off a lot on the periodic table. So later on, Moseley, he changed it. He changed it and arranged the periodic table and arranged it by atomic number. And he pretty much, that atomic number is the same thing as proton number, if you guys remember. But, he kept the entities separate. He kept the entities separate. Okay. Anyways, number 2. When Mendeleev arranged the periodic table, he decided that some elements should be grouped based on when Mendeleev did it by atomic mass, he was going based on more of, like, remember physical and chemical properties? He was more looking at the properties of the elements, like the physical and chemical changes and all that. So basically, mainly it was the properties that he was looking at. So it was based on properties. Even if it meant placing them out of atomic order. Okay, so he was placing them out of order. So he really, really, really looked different, very, very different from this. Okay, it was similar but different. Okay, but Moseley went back in there and he perfected it, and we still use how Moseley arranged it. Okay, so let's look at number 3. Elements in the same. Well, basically, I don't know if you guys remember, but groups are they're basically vertically. Okay, they have families. So all of these, like from lithium to to cesium to francium. So all of these right here, they're the same family. They react the same, just like you have a family, and you're very similar to them or somewhat, but they're your family, so you all have certain characteristics that are the same. Okay, so elements in the same group, okay, or family, because group and family is the same thing, have the same, they all chemically react the same. They have chemical properties. Okay, now the periodic law states that the physical and chemical properties of elements are periodic. They are periodic functions of their atomic number. Again, the current periodic law is based on atomic number. Okay, and yes, it's periodic, just like periods. Just like you have a period, it's a cycle, right? That you go on like every day, going to your classes, and you have periods. So all of that, that's how it's organized. It's very similar. Okay, so where is the periods? The periodic table. So these are horizontally. So these are horizontally. Those are your periods. If you guys remember, those are the shells, or the energy levels, or the circles that go around the nucleus of the atom. Okay, and horizontally, think of it as a horizon. Okay, where is the groups or families of the periodic table of the elements? These are vertically, and this go up and down like that. Okay. Now it says label the valence electrons in each group. So you gotta remember the valence electrons. So these ones are, okay, so these are 1, 2, okay, 3, 4, 5, 6, 7, and 8. Okay. Okay, so now it says also to label the ions in each group, including the cations and the anions. So, it's very. So now we're gonna look at the ions. Okay, the ions are the cations, the plus and the minus. Those are your cations. So for ions, we're gonna go ahead and put +1. This is +2. This is +3. And now here, now it's going to go into negatives. 4 usually varies. It really, really varies from positive to negative. Okay, so we'll talk about that more closely when we get to bonding. So this was -3. This was -2. And this was -1. Okay, and this one has 0. So 0, that means 0 charge. Okay, now you could easily type this up here. Okay, you can easily type it up in there. Okay, so group A. Now we're looking at groups and families. Okay, remember these are families. Okay, you could easily type this up next to it. Again, these are families. So this first family, remember it's alkali family. Alkali metal. Now these are all metals on this left side. Group B is alkaline earth metal family. Group C, those are your halogens. And then group D are your noble gases. Okay, circle the transition metals, and also you're going to draw a staircase in the metalloids. So it's hard to write all this for part of your transition. So what you could do is you could just type up in the top, these are your transition metals. Okay, now the metalloids, those are tricky. Okay, the metalloids, and this says to draw a staircase. So really, you don't have to draw it, but if you want to go ahead and draw it, it's right here. Okay, what I could do instead, since you have a paper and you have to type it up, what I could do, because metalloids is in between, it's like non-metal and metal. That's all it is. That's what metalloids are. Okay, so I'm gonna give you a list of the ones that are your metalloids. So let me just make sure I got all your metalloids in here. Okay, your metalloids are it's boron. So these are your metalloids. So you could write it down. Metalloids, it's your boron, silicon, let me see, that's arsenic, and it's also germanium. Germanium. I'm just hoping I spelled it right. Germanium, also tellurium, and it's also SB is it's this one, SB. So it will be tellurium, arsenic, silicon, and boron. And SB is antimony. Antimony. So I'm gonna write it down here. Antimony. Antimony. So as long as you know that those like next to the staircase are your metalloids, basically, I mean, there's like I think there might be a question on that. So as long as you understand that these are like right in between the metals and the non-metals. Why? Because it's both. They are in between both metal and non-metal. Okay. The next one. Let's look at the next page. And now what you're going to do is you're going to use, what I suggest is you look for the periodic table that has the charges. So I did put 2 of them in there. So if you guys look at this, these are your charges. You also have it in your first page, of course. We just wrote them down in here too. So it's up to you, but in here it will show you how to write them as well, okay, as a superscript. Okay, so you do write them as a superscript, the charges. So you see how these are +1, so these are +1s, these are 2 plus. You see how some of them are 3, pluses. These are -3, these are -2, -1, and these are 0. Okay, so again, let's go ahead and do that. So gallium would be, on actually it's on the 13th family, which is third. Okay, 13th family. So again, I don't know if you guys remember, but it's 1, 2, and then it goes all the way to all across to 12. So this is 3 all the way to 12, and then this is 13, 14, 15. These are the group numbers. Okay, so and sometimes they have 3A as well, 4A. It's the same. You see how the 3 matches with a +3, or well, especially the valence electrons. Not much of the ions, a little bit, but mainly you do have to understand the group number, okay, as well, both group numbers. Okay, so anyways, gallium is right here. So gallium will be +3, so it will be Ga +3. And again, you don't have to write it as superscript as long as you understand that it's a superscript. Okay, and this part right here, those are your metals. Okay, it is still a metal. Okay, let me see here. This one's a positive, so it's a cation. And then valence electrons, well, that one, we might as well use this one. That one is for gallium, which is right here, will be a 3. Okay, and then nitrogen would be that would be a -3. So nitrogen -3, and nitrogen is a non-metal. And then this is a negative, so this is an anion. Valence electron is 5. Fluorine is right here, so -1. So you just put the symbol and then -1. This is a non-metal, right? Because remember, non-metals are on the right side of the staircase. Metals are on the left side of the staircase. Okay, so this one's an anion. And then the valence electron is 7. Cesium. Cesium is, where is cesium? Cesium is, it's atomic number 55 right here. So that one's a +1, so it's Cs +1. This is to the left, so it's metals. This is a positive, so it's a cation. And valence electron is 1. Beryllium is right here, atomic number 4, so it's Be, +2. It's to the left, so it's a metal. And it's positive, so it's cation. And its valence electron 2. Phosphorus. Phosphorus is atomic number 15, so it will be P. And then it's -3. And then it's the right side of the staircase. It's obviously it's not a metalloid as well, so it's a so that means it's a non-metal. Non-metal is anion. Okay, and then valence electron would be 5. Okay, so you see how all the anions are your non-metals, and they're also negative. Your metals are positive, and they're all cations as well. Okay, so which group is the least reactive? So hopefully you guys remember that gases have 0 charge, so that's why they don't react, because there's no energy there. Okay, so which group is the most reactive? Well, alkali is like barely has, yeah, basically the most reactive is lithium, sodium, potassium, rubidium, cesium. Okay, and also francium. Okay, so that's your alkali metals. Okay, so now, okay, so now we're going to be looking at the definition, the terminology. Okay, so electronegativity, energy required to remove an electron. So this is how much energy so you can remove it. Okay, so that's electronegativity. You see electron, okay, and then negative, that means remove, right? So this is negative, and this is electron, right? So electron negative, right? So that's one way to remember. So that's A. Okay. Ionization energy, that's the tendency of an atom to attract electrons. So ion, remember it's a charge. Remember that it's a charge. So charges, when there's a charge there, they attract. They attract. Okay? They attract, and of course it's going to be electrons, because the electrons are the ones that are the little fleas that jump around just wherever it's more attractive. So this is E. Okay, now we're going to look at ionic radius. Ionic radius is radius. It's like, I don't know if you've seen it in math, it's a circle, and it's the measurement from here to here. That's it. That's your radius. Okay, so you measure it. So that's how fat the atom is from close, or how far away those valence electrons it is from the nucleus. So so for this one, it is the size of an atom that has gained or lost electrons. So they, like, in other words, it begins fat or it becomes skinny, right? So this one is C. Valence electrons. Valence electrons are the outermost electrons similar to a group number. Okay, and then group numbers, you guys remember that it goes from 1 through 18 if you count them across all the a periodic table. So valence electron is D. Uh, Again, atomic radius. Let me see here. Okay, so the atomic radius. So here is it's very similar to atomic ionic radius. Very similar. Okay, but this is when it remember it's cations and anions. So this one, atomic radius, is the size of the atom. It's B. So again, radius is basically, it goes from here to here. It's a measurement, okay? But this is how big, this is how many electrons there is in there, okay? And keep in mind, it has a lot to do with the measurement from the valence electrons. This is the valence electrons, the outside, and then this is the nucleus. Okay, so the size of the atom, it varies, it really does vary. Okay, we're going to be looking at that. Which element has the greatest electronegativity on the periodic table? So the greatest, and then on that you're going to have to look at your periodic tables. And I'm going to be looking at that. So if you look at that, greatest electronegativity. So electronegativity, if you look at it, it increases as it goes from left to right, and then and then it increases. Actually, it gets, so it goes. So these right here are the highest, but the most highest, because electronegativity increases, it decreases as it goes down. So these on the bottom are lower than the ones on the top. So the top ones are the highest on electronegativity. Okay, so you would have to look at this and then this. Oh, it decreases, so that means the top ones are the highest. Okay, so in here, the best one would be from the periodic table, would basically be the highest would be fluorine. Okay, it would be fluorine. Okay, and then the element that has the greatest atomic radius. So if you guys remember how it becomes, a good visual would be this one. You see how it becomes, you see the biggest and fattest ones is this ones right here. So as it goes down, so we look at the periodic table, which is the one in that corner. So it's right here, francium. So this is francium is the fattest. Okay, that's the highest. And then ionization energy, which one's the greatest? So again, ionization energy increases. Ionization, it's the same thing. So it will be somewhere on the top. So this one will be, again, fluorine. Okay, now it can't be gases, you guys, because remember, gases, they don't react. They don't have any of this. Okay, any of the electronegativity and ionization energy. It doesn't have any attraction. So that's why it cannot be a gas. Okay, so don't. So I know you probably have that in your mind. Again, it has to be somewhere in the halogens, because halogens are super. I mean, they are reactive. They are. I mean, they're -1. They need like 7. So they probably, so they need to gain. Okay, so it's very, very highly reactive. Okay, anyways, so let's look at number 9 now. And so So now in here, we're going to be looking at how many valence electrons do the following elements have. So again, we can use this one as a guide. Okay, so oxygen is, again, oxygen is 6. Ion charge is -2. That's it. Very simple. So xenon is a gas. Xenon has 8 valence electrons and has 0 charge. Okay, 0. Okay, strontium has a 2. Okay, strontium is right here. Has a 2 and then +2. Boron is a 3. So that's 3 right here, boron, and that's a +3. And then chlorine has a 7. So chlorine is a halogen, so it's a -1. Okay, so let's go ahead and continue with the next page. Okay, so valence electrons they remember valence electrons is everything. All it is how many coins you have with you, and let me negotiate. That's what it is. How much? It's like you're playing, poker, or you're paying, so you're negotiating in a car. That's how much money you have, and how much are you gonna lose, or how much are you gonna keep, or I don't know, that might not be the best example, but basically it's lost, gained, and shared. They're all of them. Okay. So on this one, okay, so you're looking at group 2. So if you guys remember on group 2, basically the atomic radius gets fatter, right? As it goes down, it gets fatter and fatter, fatter, fatter. So it's skinny to fat. Okay, it becomes bigger as it goes down. So the good thing is that they gave us group 2, only group 2. So all we have to do is make sure that it's arranged in the order of increasing. So as long as it goes in order, so like beryllium, magnesium, calcium, okay, calcium, magnesium, beryllium. So it can't be this one. Okay, because this one's going, actually, this is going from fat to skinny. This one's going from skinny to fat, actually. Okay, and then barium, radium, barium, radium, and yeah, they're out of order. Strontium, radium, and I'm sorry, yeah, that one's out of order too. So it has to be in order exactly, because, that's the one that's next. So in here it will be 8. That's the answer. So this one, a lot of students get confused, like, what the heck is it talking about? It's actually not that hard, okay? Which is most likely value. So if you look at this is 2.0, this is an electron, you know that they're in order. So like, look at this, 1.5, 1.8, 2.1. That's in order, right? So it should be the same in here. So it should be the answer should be between 2.0 and 3.0, which is the only one that is in between that. It can't be 3.1 because that's afterwards. It can't be 1.1 because that's before 2.0. It has to be 2.5. It can't be 1.2 because that's right here. So they're trying to find out what's in the middle. So it would be C. Okay, so for this part, let's use the periodic trend. So on this part, the atomic radius increases from top to bottom, right? So as you guys can see, from top to bottom, it says increases. So it increases. Okay, and from left to right, it decreases. Ionization energy, again, from top to bottom, it decreases. Ionization energy from left to right, it increases. Electronegativity, from top to bottom. Well, basically, ionization and electronegativity, it's the same thing. So in this part, we're just gonna basically do this very similar to what's here, but it's more of a visual. Okay, it is more of a visual. So, but it's a little tricky. Okay, why? Because of the arrows, the way it's pointing out. Okay, so if it's going from right to left, if you look at it, that means the atomic radius will be doing the opposite. It will be, instead of decreasing, the atomic radius will be increasing when it's going from right to left. So it will be atomic radius. And I'm going to put an up arrow to mean increase. Increases. Okay, that's what the up arrow means. It increases. Okay, now electronegativity and ionization always come together because it's the same thing. Okay, so we'll use the bottom line from left to right. You have it here, ionization energy increases. So ionization energy and electronegativity, they both increase. So again, they both increase. So again, the arrow up means increasing. Okay. The next one on the left right here, as it goes from top to bottom, you know, and it's right here. The atomic radius, what happens here when it goes from top to bottom, that one increases. So atomic radius, that one increases. Okay, and then here from going, you know, from the bottom up, okay, that one is increasing as well. Okay, so ionization, and remember ionization, electronegativity is the same, and electronegativity, they're both increase. Okay, so as you guys can see, it was mainly that they all increase, but in this way, they go to basically they go to the left, they go around. Okay, it's basically counterclockwise. If they go like this, counterclockwise, that means they're all increasing, all of them. Okay, that's one way to remember it. Okay, so now electronegativity. Electronegativity on W right here. So keep in mind this is S, P, D, and then of course the bottom one is F. But really we're just playing with S, P, D, F. So if you need a guide, I give you several of these to help you out. So really what it is just really that's, you know, one, and now keep in mind that this right here is an S. Okay, so all the S's, that's S1, S2. Now keep in mind that there's the period numbers also count 1, 2, 3, 4, 5, 6, 7, except for D. Okay, but since we're not doing Y, you know, we don't even have to worry about, nor Z, we don't really have to worry even about D. It's really just SP on these two. Okay, so here it will be 1 S 1, because for W we want to get to this one, right? So 1S 1S1, 1S1, 1S2. So I already did those two, 1S2. So you always put the last one. Okay, so the next one will be 2, 2, and then S, and then that's 1, 2. Okay, so you already did that. And then the next one is 2, and then it's P, and then it's 1, 2, 3, 4, 5, 6. So we are pretty much done with W. Okay, now for X, you know that you're going to go through all this. So we just rewrite it. 1S2, 2S2, 2P6. Okay, but now we're going to continue with 3, 3, and then it's 1, 2, 3s2. Okay, so we already did that. So now it's 3p, and then it's 1, 2, 3, 4, 5, 6. So it will be 3p6, and we're pretty much done. Okay, so the next one is on. This next one is pretty simple. I know orbital diagrams could look scary, but really, bottom line, really just count the arrows. Okay, just count. Remember how I told you that the arrows represent the electron number? The electron number, which is the same as proton number and atomic number. So in here, we're going to be looking at 4 arrows. So that means it will be beryllium. That will be atomic number 4. So this is beryllium. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that will be atomic number 12. That's magnesium. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 is chlorine. And that's it, you guys. That's a wrap.